So we've got a series of 4 talks to close the session today. And the first one was Dr. Matt Etterson with Hawk Ridge. Dr. Etterson is a member of the board of directors and co-chair of the research committee of Hawk Ridge Bird Observatory. He received an undergraduate degree in mathematics from Yale in 1987 and a PhD in conservation biology from the University of Minnesota in 2002. He holds an adjunct professorship in the biology department at the University of Minnesota Duluth and is a member of the graduate faculty in integrated biological sciences. In his day job, Dr. Etterson is a research ecologist at the U.S. Environmental Protection Agency in Duluth, where he leads research on the effects of environmental contaminants on birds. Dr. Etterson has published about 65 peer-reviewed articles in a diverse array of scientific journals.
Can you do it so in notes view so I can see my awesome.
And then yours is right there. You should be able to see your notes.
All right. Well, looking at my subtitle here, I guess Clinton and Kara are probably saying, "Oh, there goes our schedule." But let me just say, in all seriousness, it's a great honor to be here representing Hawk Ridge Bird Observatory. You'll notice that neither my name nor my email address are on the title slide, and it's not because I don't want you to email me. It's because I'm not the author of this research. This is an organizational talk. I'm here representing the organization, and the number of authors on the research I'm about to talk to you about would more than fill this page. And I'll mention some of the luminaries who've conducted that research over the years, but I can't possibly mention everyone. So the only thing I will take credit for here is any omissions or errors. Those are entirely mine. But let's get into that billion years. So to understand Hawk Ridge, we need to understand the geological land formation that allows it to exist. So Proto-North America started busting apart a little over 1 billion years ago in a stretch fault, which created this great hole that you can see the magma coming out on the left-hand side there, which subsequently filled with sediment and magma. The glaciers came along and sculpted that and left us with both Lake Superior and the ridges adjacent to Lake Superior, which are critical geological formations that allow the migration to occur the way it does in Duluth. I have to talk about another cataclysmic event. I know all my students are probably rolling their eyes because I talk about dinosaurs every time, any chance I get. So the next cataclysmic event occurred about 1 billion years later. And I want to draw your attention to the left-hand slide. It's really hard to see and to perceive when you first see it. But if you look just, do I have a pointer here? Maybe I can walk over. So this is South America, North America, India on its way to crash into Asia. And the red, the really dark colors there are showing you the height of the tsunami that was created as a result of the asteroid impact. And that this just came out this year. That's why I wanted to put it up here. That wave was several hundred meters high, even out into the Pacific. So the extent and the magnitude of this cataclysmic event really can't be overstated. And the subsequent environmental changes resulted in the extinction of the dinosaurs. Terrible, sad, but a great opportunity, right? So this gave rise to the mammals, boo, but it also gave rise to an explosive radiation of birds. And that allowed these peculiar feathered dinosaurs to diversify and occupy the great range of habitats and locations in which we see them today. So that's the sort of long, deep history of why we see the migration we do at Hawk Ridge. There's also climate and biome acting with the geological events, the past history, to produce the peculiar conditions that we see that favor the migration. So we're largely I'm talking about birds of prey here, so we're largely counting raptors that are breeding in the taiga, the boreal forest. They're migrating over the top of the prairie potholes in the Great Plains, and then coming down past Duluth. They hit Lake Superior and are funneled along the shore and along the ridges using the thermals created on the shore of Lake Superior. Right past us, at the tip of that arrow, where we can trap them and count them. So getting a little bit more towards our time, Hawk Ridge was known in the first half of the 20th century as a great place to go and shoot birds of prey. This really gave rise to Hawk Ridge Bird Observatory when the Duluth Bird Club was formed back in the late 1930s and into the 1940s. And their original mission was a campaign against shooting raptors at Hawk Ridge. And this was led in part by Jan Green, pictured here, but also Jack Hofsland and many others, who worked to increase awareness, enforce anti-shooting laws, and increasingly, frequently, count raptors migrating past Hawk Ridge. 1972, 52 years ago, is what we consider sort of our inception. This is when Duluth City acquired the land then referred to as Hawk Hill. It was rededicated at its Hawk Ridge Nature Reserve, which it's known as today, and it's also the year in which daily hawk counts began, and they were initiated by Molly Colbury, and the banding station was opened by Dave Evans. 72 was a banner year for conservation. It was also the creation of EPA, and the Endangered Species Act came from 1972, so a great year. So our research is founded on two data streams. We count about 70,000 raptors per year, and we trap anywhere from 3,500 to 4,000 raptors a year. In the early years, this was our research. This is what we did. We counted and we trapped. Today, this is the foundation for what we do. And we do all kinds of things with these data streams that now are 50-year records of these birds. And what I'm going to try to do, I can't possibly tell you about every project, but I'll give you a flavor for the kinds of ways in which we've leveraged this work. And I'm going to do that using our publications. So there are 127 publications, peer-reviewed publications, that have come out of research at Hawk Ridge. I'm showing you screenshots of a couple here on the left. And you can see they come in a variety of formats. There's full-fledged journal articles, research notes, theses by graduate students, books and book chapters. For the moment, I'm not going to distinguish between those. I'm going to lump them all together, but I'll come back and talk about graduate theses a little bit more in a bit. So what are we studying? I went through these publications and asked myself, what do we do? What is it we do at Hawk Ridge, right? I'm supposed to know that. So I looked at all these papers and classified them by the subject matter of the journal article. And by and large, unsurprisingly, we're studying bird migration. Who knew, right? So that's what we do at Hawk Ridge. We also study status and conservation, distribution, and vagrancy, where I was surprised, and you can see a picture here of Abby holding a northern shrike. That's a cue to tell me to highlight that we do a lot with non-raptors. We're doing a lot of work. Almost 20% of our publications cover some aspect of a non-raptor ecology or life history. Now, as you go further down these bars, so the length of the bar tells you the percentage of the publication of our publications that deal with that topic. And I should point out some, you're probably looking at those bars and saying, wait a minute, that adds up to way more than 100%. That's because our papers generally cover multiple topics, and so there'll be multiple topics in there. But as you get down into those topics, they're sort of less than 10%. That is by and large, not entirely, but by and large, our more recent work that has taken these data streams, the raptors that Frank is trapping, the count data stream that we have for now for 50 years, and using them as primary sources for secondary research that we do on top of that. And that includes studies of demography and connectivity, injuries and disease, eruptions and cycles, bird cycles, climate and phenology, molt and plumage. We do a lot of methods development. We're increasingly studying diet and trophic level of these birds, in part for to support our environmental contaminants research. And we're starting to look more at breeding birds, and I'll give you an example of that today. So we're really starting to diversify the breadth and range of topics that we cover, but it's largely because we have this foundational data stream from which to draw. So our papers are well cited. If you look at these citations, you'll find over 800 citations to them in the primary literature. 74 of them use the counting data. 85 use the banding data. And again, that adds up to more than 127 here because some papers use both. But you know, it's a substantial and well-cited research portfolio. And one of the things I want to convince you and leave you with today is that this foundation now puts Hawk Ridge at sort of a pivot point. We are at an inflection point in our history, and we're really in, I think, the beginnings of an exponential growth curve in the kind of research that we do. Here's an example of some of our past work on northern saw-whet owl migration using banding dates combined with a variety of banding stations across the eastern United States. And you can see with latitude on the horizontal axis here and day on the vertical axis. So that's calendar day. We're probably at about day 334 or 35 here right now. So we'd be at the top of that curve. And you can see that banding date goes down with increasing latitude. That's not very surprising, right? Because you sort of imagine this broad front migration of saw-whet owls moving through eastern North America. I'm going to come back to that topic, so that's foreshadowing. Here's another really interesting case of how people have used our data. This is using our count data stream to look at when birds are migrating. So the 0 there is a standardized average date of migration for the various species you see on the vertical axis. And those birds that are, whose regression slope of migration, so the rate of change of their migration date, those birds that are to the right of that line are birds that are migrating later. Those that are to the left of that line are birds that are migrating sooner. And so this appears to be a strong climate change signal saying that raptors are migrating later in the season, presumably due to conditions allowing them to remain on the breeding grounds for a longer period during the fall. This is another topic I'm going to return to from our student research. But before I sort of conclude the Hawk Ridge legacy and the Hawk Ridge past, I do need to mention the folks who've collected all this data. And there are many, many of them, but a few deserve special mention. Dr. Jack Hofsland from the University of Minnesota, Dave and Molly Evans, Jan Green, and of course Frank Nicoletti, who's sitting over on the side here, are really the folks who've done this. And this is the model on which Hawk Ridge has managed to do this. Incredibly dedicated people who have come to Hawk Ridge and who have made this happen, who've essentially made this happen. I think that, as I hinted, we are evolving as an organization, and the foundation that these folks have laid for us, I think suggests that we may have a very interesting and exciting future. So I mentioned that some of the papers that I summarized for you were done by students. Here's a list of all of the graduate theses done by students at Hawk Ridge. And if you notice, half of these were done in the last 10 years. And so we're seeing, as with our other publications, a kind of exponential increase in the amount and fervor, if you will, of research being conducted at Hawk Ridge. And a couple of these folks are on the program today. You heard from Steve already, and you'll hear from Hannah in a few minutes. Hannah, you're not listed here because you haven't graduated yet, but next year. So we have a really dynamic cadre of graduate students working there. And what I want to do now is highlight some of the great stuff that they're doing. So this is work done by Ted Kyle, looking at mercury exposure in raptors. Mercury is a bioaccumulating contaminant. It's methylated in freshwater systems and bioaccumulates through invertebrate food webs into higher trophic animals, such as aquatic mammals, but also predaceous birds. And so the two bar graphs on the left here are showing the mercury exposure of a variety of raptor species and split out by male and female, or the green one is when we can't tell, and their mercury exposure. And if you can, I don't know if you can read the axes that far, but the scales are different. On the adults are on the bottom and the juveniles are on top, but the scales are different. So adult exposure is much higher than juveniles, as you would expect with a bioaccumulating contaminant. But we were also able to show, so this is a picture of Merlin here, the scatter plot. I want to draw your attention to that. I didn't draw a regression line through there, but if you look at it, you'll see that that's showing the amount of mercury with hydrogen isotopes. So basically, this is a trophic effect. The higher that a bird is feeding at a trophic level, the more mercury that bird is being exposed to. Even so, the bottom histogram is suggesting that most of our birds are experiencing exposures that are probably not of high concern. There's a few that are in moderate risk, but most of them are in low or no risk. All right, so this is Steve Colby's work. I was just told I have 5 minutes, so I'm going to go fast here. Steve counted nighthawks, which he's still doing. This is data reported from about 15 years. And what is it, 2008, or what is it? Tell me the date, Steve. 08 to 22, yeah. So about 15 years. And over that period, nighthawks increased in the annual counts along the lakeshore. And what's one of the really interesting aspects of Steve's work is to show the conditions under which they migrated. So that circular plot, interpret it like a compass. And the wind directions where the density is high is telling you conditions under which they like to migrate. So that was a super cool study. I'm going to go fast here because I got much more to cover. Here's Lisa Brulette, came as a graduate student and was interested in raptor diets, used metabarcoding, a DNA-based technique based on cloacal swabs to detect during migration what those birds were actually eating by matching up the swab DNA with libraries of prey items. Here is Ryan Steiner's work, so I hinted that I would come back to that. Ryan was very interested in how increasing effort at Hawk Ridge might confound or confuse our interpretations of migratory phenology. And so what Ryan showed is that, in fact, if you take into account the increasing effort at Hawk Ridge, birds are not really migrating that much later. It's just that we're counting them much more efficiently and much later in the season than we had been in the past. Now, some of them still are migrating later, but this is an example of how our students have really helped us to take a closer look at these data. This is Ali Pisano's work looking at the history of captures at Hawk Ridge. We saw phenotypes that were very interesting, including dark morph redtails, so she was working on redtails, dark morphs, and the abetocola phenotype, pictured down below here. And we were interested in how and where these birds were coming from. In particular, dark morphs are supposedly Western birds. Why are they turning up at Hawk Ridge? Well, Ali used genetic techniques to show that, in fact, Eastern birds have dark morphs. So these dark morphs were clustering more, if you look below that line, those are the dark dots, are clustering more with Eastern birds than they are Western birds. So dark morphs occur in eastern populations of red-tailed hawks. One of the persistent questions at Hawk Ridge is where are these birds coming from? Emily Pavlovic used stable isotope analysis of deuterium to start to answer that question. And you see the patches of dark spots there are individual sharp-shinned hawks or saw-whet owls or red-tailed hawks, and the general range of their source populations using those deuterium isotopes. This is perhaps one of the most mysterious birds in North America, one of the least studied. It's going to remain mysterious because Hannah's going to talk about it in a minute, so I'm not going to say anything about it. And then finally, we have Hallie Lambeau, Research Award winner who's studying American kestrels breeding and breeding productivity. As I close here, I just want to highlight that one of the things that makes Hawk Ridge so successful and that we're excited about right now is our collaborations. You heard Victoria talking about the Raptor Center and the avian influenza work, which we're partnering on. We have lots of projects with the Raptor Center, which I think is a natural partnership for us. We're partnering with Biodiversity Research Institute on the East Coast, and of course, NRI in Duluth. So, what's going to happen for the next 50 years? Lots of great stuff. These students we're training are sticking around, and we're looking forward to continued input from them. And I'll leave you with one thought. At Hawk Ridge, the sky is not the limit. It's just the beginning. Thank you very much.